AI-powered network automation, 5G and beyond, transforming industry and enterprise with 5G and beyond. This is the theme of the technical session. The session will be chaired by Mr. Jeevan Talgaonkar, Vice President and Head of 5G Solution, Reliance Jio. May I request Jeevan to come on the stage. The special address is by Shri A. Robert Ravi, Chief Technology Officer, Government of Tamil Nadu. May I request Shri Robert Ravi to join us. I am sure all of you know Robert ji. He was in TRI before he moving to Tamil Nadu, and soon we hope to see him Delhi soon. I request Mr. TV Sriram, Global Head Network Operations and Accenture TV. Yes, here. Satish K, Head of Standardization Asia Pac Nokia. Yes, Satish, yeah. Alka will be joining in some time, that's what she said. Yes. So this is the panel on the technical session. So now I invite Shri A. Robert Ravi to give his presentation, and then I request the chairman of the session to after Robert ji gives his presentation, it's all yours. Thank you.
Good afternoon, ladies and gentlemen. It's a pleasure to be around for the 5G. Now we are talking going a step ahead 6G. What I'm trying to do in the next few minutes, maybe the next 10-15 minutes, to take you around what are the opportunities that are around 6G and what is going to be the power of 6G, these opportunities, challenges, and how it's going to impact our life. We know there's going to be a lot of discussions on the applications. The applications are all emerging. People who are talking about killer application. To put very short, 5G talked about integration and interconnection of man, machine, and object. 6G takes one step further to add the gene also. So which means you're going to go in a complete virtual environment. That's going to be the reality. So which means you're going to have a XR, VR in a real-time world. So your phones and other things is going to take a next level of change where you're going to have a complete immersive experience. The 2D calls which you are having today, the calls what we make, they're all called 2D calls. So because they're two-dimensional one, it's going to be replaced by what we call as 3D calls, the holograph communication. We are going to see all the connected robotics that's going to happen. The complete utilization itself is going to see change happening. Most interestingly, we have been talking about this brain net for quite some years now. Now the vision of this brain net is going to be a realization. So we are going to actually bring in brain net and solutions surrounding it, because 6G is going to drive towards what we had, connected devices to connecting intelligence. It's going to be a complete intelligent network which is on its own. We'll be seeing some of the slides on it. And we are going to drive, especially in the nano and the bio-nano stuffs. What we have been talking about, Internet of Things, is going to go to the next level of Internet of Nano Things. We are talking about Internet of bio-nano things. That's going to be the new era. From the perspective of the customer, we are going to experience what we have, a complete metaverse environment. The way of life, what we have, is completely going to have a complete sea change in the next few years. Education sector, we are going to talk about immersive education, which means as a student, her child goes on reading, through this sensor network, I think the speakers were talking about, one of the key elements in the 6G is going to be the sensors, network sensors. We'll be able to identify what is the extent to which the child is learning, and then accordingly the teachers or the course correction happens. So that's what it's going to be a complete sea change in the education sector. Similarly on the agriculture, everywhere we are going to see we are going to talk about the real digital agriculture coming in also. As far as the telecommuting, we know because of COVID, we had a lot of issues of this video conferencing. Though we went into this video conferencing era, still the personal touch was always a problem. This is going to be solved in 6G, where we're going to have a complete telecomputing, where you'll have a holographic thing, somebody comes and sits in front, and then you start chatting, and it will be a real feel. Of course, the entire roadmap of what a network should look like has already been defined in 2020 by ITU's focus group. So that is going to be the base on which the 6G itself is going to revolve on its own. We're going to talk real intelligent cities. The word of smart is completely going to be eliminated into what we call intelligent. We're going to have intelligent cities, intelligent environment, everything is going to be intelligent, because it's going to be a real marriage of AI into the networking sphere itself. And we can keep on talking about the different applications, like as I mentioned about the brain net. So the brain-to-brain communications, when it happens, is going to really revolutionize the next Web3. Web3 is going to come, and then it's going to be a conversational image. The Census is going to be, and human interaction is going to be at a different level, where only by gestures you'll be able to communicate to anyone, even devices, etc. And be it for your health, or it could be education, or for health, entertainment, all these purposes, brain communication is going to play a real big role. Another very, very interesting thing which is going to happen is people were talking about security, how secure is the data, everything. The concept of blockchain itself is now going to move into the network, as we can see in the figure, starting from the infrastructure, even your spectrum sharing, everything is going to be on a blockchain-based driven infrastructure. You're moving the blockchain to the edges, to the core. You're going to have an overlay network for the service sector, and we have a core network on blockchain. So the entire thing is going to be distributed ledger technology, which is going to run on as the base of the 6G. Most interestingly, what is happening in the bio is, the biosphere, everything is going to what we call nano, which means we are going to have nano-robotics, which is going to go into our body, which we can feel and add the sensors. So probably you'll have your pulse oximeter nanosensor, or blood pressure nanosensor, ECG nanosensor. This brings out what we call Internet of Bio things. That's another field which is coming up. And everything is going to go on a pervasive nano things. That is another key driving application that is going to drive into the 6G. The urban space itself is going to completely go into different jig. People are talking about e-commerce sites where today we go and purchase this item. This entire step is going to change what we're going to have, a digital twin space, where you'll be able to look, feel, and sense the object before you buy. So maybe in your physical shopping mall, or your product details, or a communication with the customer, everything will go into a complete digital sphere, where you'll have a digital replica made, and the sense of touch and feel also is being inbuilt into it. That's going to be the driving application that's really going to come in. Another very, very interesting thing that's going to happen in 6G is going to be the federated learning. Morning, people were talking about how my data is secure, where the data is going to be there. The concept of the machine learning, which was a big data analytic itself, is completely moving today. Today, when the concentrated amount of data, because when you do a machine learning analysis, all the data needs to come to a common place. When the data comes to a common place, the data analysis happens. How are we going to do that? That we're going to do away with what we have. Different types of machine learning is going to come, including quantum machine learning, but the key base of it is going to be federated learning. And this has been already approved. I know in your release, somebody with the latest 3GPP has already approved this for 5G itself. So this is going to be a base on which your networks is going to be built. So where you can see, if you can have a look, you can see in the edge, every device, whatever device we have, itself acts as a database. And these database, your data, the actual data is not shared. The privacy data is always stored in your device. It is anonymized, and this data will be having a small model kept at each of the device. Each device has a simple model, and then you will have an aggregator model, then you will have a global model. So the entire concept of machine learning itself will go for a toss, and where all your protection of your security, private, everything is properly in place. We have a vision in Tamil Nadu. We call it Digital TN. We have already started working on it. It's a 5G, where what we think and dream is a collector, district collector in his district, you should have an intelligent display where you should be able to get data about everything in his district. For example, how much is today's my GST sales? How much fertilizer has been used in the district? What is the number of trucks moving in, moving out, temperature, weather pattern? Is there any commodity is going to happen? Using CCTVs, we can even do a predictive analysis. Any commotion is going to happen. So all this sort of a digital TN, which vision we have, this we have started building it in 5G today, which I'm sure will go on an immersive virtual way when 6G comes. For example, on the mobility side, we have the road data, vehicles data, traffic data going in. On the health side, personal data, hospital statistics. Even we can see why a particular medicine is more used in a particular area. Is there any particular disease in that particular area? Outbreak of any disease. All this could be very clearly understood. Infrastructure side, the buildings, the airports. Commerce, as I told you, even we will be able to track the amount of taxation that is happening. How much tax are you collected today? That information is available. In education side, agriculture, of course, agriculture, as you mentioned, we are going into what we have, digital agriculture. We talked about precision agriculture, etc. But we are going to put a real use of this. For example, a satellite map will be continuously monitoring a field of agriculture. If it can detect any locust or any insect, send in information to a common database. This database triggers the nearest BTS. Through some sensors, the drones will be activated. Then probably pesticides control and a photograph of the confirmation. Everything happens automatically. There's no human intervention at all. This is what the vision has been dreamt of in 6G. Of course, with this application, what are the key driving trends? Now, as we know that we have always a spectrum problem, the spectrum reliability is going to increase, and we have to pack more number of bits together. What is going to be the technology behind it? Now, we have been talking about, I'm sure you know about aerial thing. We are going to move from aerial to volumetric, which means bits per second per hertz per square meter, which we are talking about. Now we are talking about bits per second per hertz per cubic meter. That's in volumetric. That's going to be the sea change we are going to have. And we are talking about, for this amount of application, two very essential things are very, very important. One, the speed, which people have been talking from the morning. So at least you should need a peak data speed of 1 TB. And at least the user end, it should have at least 1 GB. So that's the speed we're thinking. And most importantly, latency. In 5G, the latency should be much more better than latency. Because in 5G, if you are trying to do a remote surgery or a more autonomous driving, the amount of reactive time should be very, very, very less. It should be in millisecond or microsecond. That's not presently available in 5G. So that 6G should be in microsecond. If you talk about the seaplane, it's going to be 0.1 millisecond, or it's U-plane, it's going to be at least 1 millisecond. So that is the amount of stuff we are thinking. And moreover, the mobility. The speed should be around 1,000. Number of devices that is going to connect is going to be 10 power 7. Most interesting thing is on the efficiency, energy efficiency. We'll come back to that in subsequent slides where we talk about the new concept of energy harvesting is coming. So no longer the devices, IoT devices. Just imagine you're going to have billions of devices put everywhere, because it's going to be a man-machine object chain working together in a 6G environment. Billions and billions of devices. You can't afford latency. You can't afford speed problems. So to take care of this, and the most important is your power. So we are going into what we call battery-free environment of energy harvesting techniques for these devices. This is another new area of research that is coming up. So that is, and another thing very important is the emergence of smart environment. We are now talking about smart environment, smart surfaces. And what are these intelligent surfaces? They are nothing but RIS. They are nothing but a reflective intelligent surfaces. What happens is, today, we have a lot of antennas available everywhere. So the cell structure is designed. You have a tower in the center of a cell, and then you have the inter-cell problems, issues all available. This is completely go away in 6G. 6G is going to think about a cell-free MIMO technology where everything is everywhere. And most interestingly, every device will have a separate antenna. That's one of the research going on. So if you say n number of antennas, k number of users, n is going to be greater than k. That's the vision which we have been thinking on 6G, which means the technology, the modulation, the multiplexing pattern, everything is going to change. Of course, we are going to be the SDM, the space division multiplexing, but an advanced version of NOMA going to come in. These reflective intelligent surfaces could tune the range of frequencies, whatever is available. And they are the research is going on in a number of ways. They're very simple. They can be made as a paint. You can paint a building, paint a glass, or paint your surfaces, any of these surfaces, which will act itself as an antenna for your services. And they consume little amount of power. It's a research on its own. So we are talking about such smart environments, smart intelligent services coming up in a big way. All of us know that in 5G we've been talking about SON, the self-organizing networks. Now this SON is going for a toss. Now we're going to talk about self-sustaining networks. So the networks itself will become intelligent. It itself will allot its required computational resources. Whatever resources allotted, intelligently it allots, and the network sustains on it. Suppose there is going to be a outage in one in one of the towers, automatically the payload of the other one is increased or decreased to ensure you have a complete ubiquitous connectivity. More interestingly, what is going to happen is it's going to be a complete convergence of communication, sensing, control, localization, and computing. Localization will be up to some centimeters. And network sensing we discussed at length. And the last thing very important is all your smartphones it is going to be on a dying era. You're going to have what we call intelligent phones. These intelligent phones itself will be so intelligent that they automatically talk. Suppose there's an issue similar to wearable devices. Some issue with your health, these intelligent devices can talk to the hospitals, get the information, even trigger ambulances on its own. The sky is the limit of the sensors, what is going to happen. So we are moving into a complete intelligent era. Going into the three essence thing which we talked about, the network sensing, the connected intelligence, the application scenarios are different. So now with the AI put into being, so the AI native communication is going to come in. That's create very essential. The AI native communication, it has its own transmitters, and it will have its own receivers. Now, more importantly, we are moving into what we call a haptic communication. Now, you know that when I was talking about in the first session, I was mentioning that it's going to become a marriage of man, object, machine, and gene. The most important gene function is nothing but is semantic communication. So the communication itself takes a different sphere. That is what we are trying to go into the AI native communication side. Network sensing, I think I was already mentioned, you'll be able to sense that you're available without any sensors available in your body. That's how the system works. As you mentioned, the localization takes up to a few centimeters, the calculation, that is possible. And the entire thing is connected on an intelligent platform. So that's what we call connected intelligence. Of course, the intelligence also moves to the edge. We'll come to the next. So that is what we call the edge AI. That is empowering your AI. So the intelligence actually happens at the devices, the edges, and then it goes to the core. So that gives you various rise of applications which we mentioned earlier. Let us see what are the enabling technologies. When you have these enabling technologies, of course, we need to have continuous area of, say, 90G. So one area, I think, morning, a lot of spectrum discussions happened it. Probably we need to have a terabit per second, means probably we should even large frequency. Very interesting network service provider's role. Everything is going to have a sea change in years to come. I just mentioned about the edge AI also. Another very, very important, of course, the earlier sessions, somebody touched upon it, was ambiguous connectivity which is across all, not only for terrestrial. It could be airborne, satellite, or underground. So it will be ambiguous connectivity. That is going to be the key. And to all drive this, a bit of quantum is also required, because when we talk about the security of the area, though we build in a lot of network security, we need to go on quantum cryptography, quantum-enabled machine learning. So quantum computing is going to come in a big way. So these new technologies are all going to be these enabling technologies. To put it in short, what is happening I'm very sure all of you are familiar with this triangle, the EMM, MTCs, and the URLCs. Now, these define what are the services, right, from 3D videos to your self-driving cars, to gigabyte in a second. But now what is happening, of course, instead of directly going to a 6G, there's something called a 5.5G. Of course, different people like Huawei come up with this vision. What they try to do is something for the uploading of your HD. So something was introduced, like upload control broadband communication, that UCBC was introduced between EMM and MTC. That was a small triangle which we have brought in. And the other one was on the real-time broadband communication. That was another thing. These two came up. Apart from it, on the user side, a small bit of human interference, that is human-centric services. All the human-centric services came in, that is the HCS. That was the 5.5 if you keep it. The real 6G vision is going to be an extended version of this EMM. So with the cognitive agile EMM, that's what we call it, the real-time broadband. This is going to be extended one. Of course, on the URLC, we are going to go, lot of devices going to add density. So we are talking about extended density URLCC. That's going to be an extension of it with human-centric services. Of course, on the MTC, you're going to see the UCBC and the COC, computer-aided oriented communication. That's another step which is going. This is going to really bring in various services, as we mentioned, Federated Learning, AI, network, Industrial 4.0, etc. The key thing is this triangle will slowly go into what we have a complete sea change on new media, new service, new infrastructure. That's what we talk about. We were talking about security in the morning. For that, the infrastructure, the new infrastructure builds in something called trustable infrastructure. So you build the infrastructure itself as trustable infrastructure with federated network and a complete integrated terrestrial communication, which I mentioned between terrestrial and the satellite and the airborne stuffs. More interestingly, they are even planning to bring in drone BTSs, flying BTS. That is what we call flying BTSs, which will be ensured. Because, you can't have any single point without any coverage available. In a 6G, it should be a complete coverage, carpet coverage. To achieve this, different types of technologies needs to build in. Of course, the new media, it could be wearable glasses, as I mentioned. The smartphone era will slowly die down, and everything is going to be using smart, maybe glasses or shoes or watches or tabs, all intelligent devices connecting together. And on the media side, it will all be virtual. Your education, your painting, tourism, everything becomes virtual with a real new infrastructure coming into place. That brings into what we have the three key important connectivity. That is what we call the sagging networks. As I told you, this, when you have this ubiquitous connectivity, your surface, air and ground information network will become a reality. So that's what we call the sagging networks. That's becoming a reality in 6G. And everything is going to be intelligent, as you mentioned. It's going to be completely intelligent, very important, controllable. Every device, suppose you have an RIS painted on your wall, these wall devices also could be all controlled using an RIS controller. The RIS controller will trigger which particular device is which antenna. So every antenna of every user to any antenna is easily controlled using an RIS controller. So that is what we are thinking in an RIS assisted system. We are talking about holographic communication. We are talking about deep connectivity. All this is all possible with the advancement in technology, what we think about. So to put it in a nutshell, these are the various dots of the technology that is all evolving. Concepts of everything connected to a network, everything as a service, semantic communication, augmentation of human intelligence. The backscatter communication, which was already there in 5G, itself is now going to be used in a better way for communication. That's another one. Of course, the human-centric wave framework. We are most importantly, the quantum also comes into with QC-assisted communication. That's another area of research going on. The spectrum, I have just mentioned, any range of spectrum could be used in any devices. We are not going to be having any spectrum sensing. So a new technique for spectrum sensing is coming into being, be it blind detection, eigenvalue, cyclostationary. These are different technological advancement that is happening. We are slowly moving into what we call time convergence. So everything is converged into a common family, what we call the time convergence. We have the quantum artificial neural networks coming in. The sixth sense, when all this comes in, you're going to be intelligent network. It's completely, that's what we call, can we develop what we call a sixth sense communication network? That's another area of research. So it's a complete AI solution with intelligent cognitive self-sustaining networks. We were talking about QoS earlier, quality of service. Then slowly we came about different types of the quality of service variants. Now we are going to talk about quality of life as a parameter for these services. So QoL, that is run on what we call generative adversarial networks. So as you can see, you have new technology is going to come in and really do a thing. As far as the infrastructure is concerned, new infra with infrastructure, with fusion infra, innovation infra, integrating ground, UAV and satellite is going to be the real game changer. And another very interesting thing of the entire stuff is two very important technology. Fluid cells and fluid antennas. Let me come back to this. With this, The driving applications drive the trends, and the trends are driving the various enabling technologies. One of the research paper, of course, puts and predicts 6G as this graph. Very, very interesting graph, very lot of data available. I was mentioning about fluid cells. Fluid cells are any BTS automatically depending upon the load capacity could change its altitude, its information, so they are become fluid. That's a new technology. Cells are becoming fluid cells. Fluid antennas, very, very interesting research going on. Any antenna through a type of fluid material like mercury will be able to tune up to a particular spectral wavelength in the transmitter. We talked about the integrated frequency band transmitters which use fluid antennas. It could be ST fluid antennas. So as we can see on the right hand side, you can even start from your body area network, sensors, massive information, gateways, completely. On the other side, we have the reflective intelligent surfaces, or even your walls, large intelligent surfaces could also act as a wall. Device to device, fluid cells, vehicle to vehicle, and it will be complete integration. You can see on the left-hand side, from your underground, that is from your submarine to your space shuttle, you'll have all the interconnectivity happening smooth, true broadband speeds. So in short, massive IoT, massive MIMO, tiny cells, cell-free, fluid cells, wave, multi-terahertz, visual light communications, another very new concept is coming for the smart homes. If you can see the figure inside the smart homes, it is all similar to Wi-Fi. We have the VLC in a very big way coming up. Fluid antennas, large intelligent surfaces, vehicle to vehicle, device to device, NOMA, intelligent cacking. Cacking is intelligent. Energy harvesting. As I mentioned, the devices will become intelligent. It can do harvesting. Wireless backhaul and an integration of all these satellites, which will actually drive the entire quantum system. Of course, this is a rosy picture of what is going to happen in the 6G we have projected. Each one of these technologies are having a problem and research is going on. I wish each one on this room to at least go back with one or two of these technologies and see how we can take this forward from the Indian perspective. Let us take the terahertz band communication. We need to have this fabrication testing of antennas, real-time control algorithms, communication protocol coordination is an issue. Intelligent, I was talking to you about the intelligent communication environment, the surfaces. You need to see the trade-off between the dimension and the energy consumption, the compatibility, standardization, how we are going to use it for the existing environment, how we are going to introduce AI-driven. These are some of the open problems. And the AI, the pervasive, we are going to talk about the pervasive AI. Well, what is the generalized algorithms we need to use? What are the effective comparison metrics that we need to bring in? How the network should be automated? What should be the accurate intent that is required? We talked about reconfigurable transceivers. Of course, it's a very novel design, but this design will have all spectrum communication. How do you do this reprogrammable circuitry? How the interconnects will happen? What are the type of antenna? They require novel integration and real packaging techniques because you have to pack number of devices in a small 1 square centimeter of area. And the backscatter communication is going to have a real spectral and energy efficient thing which we talk about. And of course, we talked about the Internet of Space things, combining all the ambiguous connectivity. How we are going to design a multi-band transceiver that is going to take care from satellite down to submarine. But it should also be low latency because immediately it should have a reference, low latency, high speed. How are you going to hand over it? And of course, we talked about the cell-free MIMO. Because no longer the honeycomb cells are going to disappear. We're going to go into what we call a cell-free MIMO environment. For that, how are you going to use the user scheduling? How are you going to do the optimization of the APs? Because you know that in any room, I told every antenna is going to be on a user. You're going to have n greater than k. So how particular AP will take a particular antenna. That requires real optimization techniques. Internet of Nano Things. The power efficiency model, biothings, quantum communication. Quantum communication, we talk big, but the very, very key thing is your quantum error correction. The moment the quantum computing happens very, very fast, but the problem of quantum error correction really takes over. For example, to do one calculation, you need to do X amount of computation to have the end quantum error corrected. How are you going to balance it? These are some of the open problems. If these problems are being completely rated, we can have a clear vision, 6G, what I talked about, a reality. I'm sure you should be ignited of these opportunities that are available. Let us take back one of these areas, and I'm sure we should start working on these areas to make 6G a reality. Thank you.
Good afternoon, all. First of all, I would like to thank Sri A. Robert for such a nice 360-degree view of 6G technology. And this reminds me of a book, Homo Deus, if at all you had read it. It's from Yuval Noah Harari. He's one who throws a lot of ideas. When I looked at the plethora of 6G applications which were cited by Sri Robert, it reminded me of the writings of Harari. So thank you very much. And this is no surprise, because whatever little I understand of Indian market, I had seen with respect to 5G adoption that the government is at the forefront compared to the private industry. There are many PSUs who are seeking 5G. They have a budget to create the test beds. They have the budget to roll out 5G in an actual commercial environment. Let me give a few of the cases where we clearly see 5G taking off. Because to talk about 6G without touching upon the very substrate of 5G, which is pretty new in India, I think it would be like being very off ground, and I don't prefer that. And our event organizer today, he asked me to touch upon a few of the 5G use cases. And one of the uniqueness of Shashi is that he always puts the speakers in a very odd spot, primarily because he picks up very future-centered topics. So thank you very much for making us read a lot before coming here. So there are a few 5G use cases which are really taking off in India and commercially taking off, let me tell you that. So one of the use cases is using 5G technology as a fallback option to existing SD-WAN network. I'd clearly seen that most of the manufacturing companies, they have MPLS as kind of powering their SD-WAN network today. But what if the primary link of the MPLS goes down? Then they're looking at 5G as a fallback option. And that's where we clearly see an opportunity to monetize 5G today using the fiber and using the 5G front haul. There are a few other manufacturing companies, and why manufacturing I'm saying again and again, primarily because India has 18% contribution to the GDP coming in from manufacturing sector. So it is very obvious that that is the sector which will throw a lot of challenges to us and also will throw a lot of ideas to us being a telecom operator. And they would ask us to design the use cases for them to be monetized. One of the things which I see still in a test bed is autonomous vehicles. And that is a future use case for 5G, for 6G, sorry. Because the kind of latency and the throughput that it requires is not likely to be served by 5G today. So, but the use cases which are dominantly been exploited on 5G is robotics. And Jio had actually foreseen the potential of robotics much ahead, and that's one of the reasons that we acquired a company called Adverb. Earlier, the telcos were of the mindset that we would not go ahead and invest ourselves into making the use cases, but if you want 5G to take off, there is no other alternative. You got to invest in the use cases. So the robotic company was taken over, and now what is happening, is that we are putting a 5G modem inside the PC of the robot. Then I just have to embed a SIM card as an auxiliary unit into the robot, and it starts working. That's it. So it becomes very, very easy as a telco to power up the robot using 5G. Otherwise, you need to carry a big modem, take it closer to the robot, keep it on the top of the robot, and you'd not believe in a manufacturing environment there are hundreds of robots running on the same floor. So if I carry 100 auxiliary units of the 5G modems, which are half the size of the robots, nobody's going to accept it commercially. So you got to really get inside that equipment to make sure that it becomes 5G ready. And that is an effort. And we are taking that effort to make sure that the entire ecosystem comes to life so that it becomes embraceable. Let me give another example of the AR glasses or the VR glasses. It's very easy to talk about it, right? AR and VR. But to make one use case come to life, it takes your blood and sweat. And we have acquired a company called, I forgot the name of the erstwhile company, but now it's called GeoGlass. And it helps us do the augmented reality. And we have been putting straightway a 5G SIM card inside the goggles so that it comes to life. And I'm able to inspect the digital model of the equipment or whatever is running in a manufacturing setup using the glasses so that I'm able to figure out if at all there is any anomaly with respect to its physical design. And I'm only able to fix that anomaly as a quality engineer. It's helping really on ground. With investments being made into the MEO and the LEO orbits for the satellite communication, I think that's going to be handy for the 6G as it evolves. Finally, let me just give few differentials with respect to 5G and 6G. What is it that's going to be very different with 6G, which is not there with 5G to be offered? I think even after having secured the best of the spectrum assets available in India, 1000 megahertz of midband and, 1000 megahertz of high band and 100 megahertz of midband and 10 megahertz of low band, we are able to give 1 Gbps throughput on a midband. 1 Gbps on a midband, right? So what happens is with a millimeter wave, that is 26 gigahertz, CPEs being ready, and we being able to really use all 10 carriers of 100 megahertz each in a 1000 megahertz chunk, I would be able to reach 10 Gbps throughput on 5G. So from 1 Gbps on midband to 10 Gbps on millimeter wave is what 5G can give you in reality. 6G can give you minimum 100 times of that. 6G can give you 1 Tbps. That's kind of the higher circuit of 6G. It starts from 100 Gbps and it could go up to 1 Tbps. Similarly, in the context of latency, because when you talk about throughput, you got to also speak about latency. So the latency that we really witness in the network today with 5G is 25 millisecond down to 5 millisecond round trip time. Is there a potential for that to go down with 6G? Yes, 1,000 times to 1 microsecond. So I think that is the potential which 6G as a technology is going to offer to all of us. And I work for an Indian company. So I think there's a lot of pride that India has set up an ITU office now. And Indian government has taken a very forward-looking approach towards 5G technology. And more, I see that the percentage of software in 5G and 6G is much more compared to the percentage of the hardware. And with that, surely, India is going to have a very natural advantage which we could explore for many years to come. Until 2030, when we are talking the test beds of 6G to be readied, I think we clearly have an advantage of using our software prowess. But that doesn't mean that we are not ready for hardware. I only expect that our semicon story comes together very well, because that's the only layer of dependence that we have in terms of importing the components, and we are not able to build it up in India yet. So the moment we are ready to do that, I think the entire 6G will be manufactured in India the way the 5G is getting manufactured in India, except the semicon. But going forward, until 2030, we would even have the semicon made in India, along with the full 5G gears and the 6G gears. And we would be the suppliers to the world around us. So the last point is AI and ML, which my co-panelist talked about. I think that's going to be really tested to the hilt with 6G. It's already into practice with 5G. And the MEC, which is kind of an NMR today, I think we really need to get past it. and put it to practice so that the multi-access edge compute is put to real use, because most of the 6G network, the compute and the storage and even the decision making is going to happen at the edge of the network. So with this short note, I really want to give some time back to you. So thank you very much for inviting me here, Bharat Exhibitions, appreciate it. And now I call upon my co-panelists for their address. So I'm happy to introduce Mr. Satish K to all of you. He is the head of standardization Asia Pacific at Nokia. I'm your ex-colleague, by the way. Please come on the stage. Thank you.
Then we started in a very small way to start supporting machine type communication using 4G. Then 5G focus was more on this industrial type of communication. As you see, the number of applications that keep getting added, that have to be supported by the network, keeps on increasing from one generation to another generation. And with 6G, now that people have tasted the ability for the same network to support multiple applications, things have really been taken to the new level. So you talk about so many different types of applications, but each of these applications have very different requirements. So you essentially need, for supporting, say, these kind of applications, maybe like 20 networks. So it is like supporting 20 generations in one generation. But obviously, as you know, we cannot afford to do that. I mean, we as technology vendors would love to have 20 different varieties so that we can sell more boxes, but that's not economically viable. So we need to create a network or technology that can support these different types of applications in a way that that is also efficient in terms of the amount of resources that can be put. As you know, spectrum resources, energy, as well as compute, everything is not infinite. So therefore, there is a need for us to create a system where we can very efficiently manage such a wide variety of applications which require wide variety of configurations. Each application requires a specific configuration for it to work best, and all these things have to coexist. So you would give the task of managing such a complex thing to probably the most brightest species on Earth, humans, but as you know, humans cannot do that. So therefore, operators who have to manage such a complex network would look towards machines. Okay, and that's what is the motivation for me to talk about cognitive autonomy and the digital twin, because although when we started in 4G, there was a concept of self-organizing networks. I mean, that was a beginning where we had, algorithms that tried to do the reconfiguration management that would have earlier done in a manual way. But now going ahead with such complexity in the network, relying on AI is not an option at all. I mean, it is an imperative for us. So with that background, I'll slowly move into my presentation. So I'll start with a little bit of definition, because the word, these terms, autonomy, cognition, like AI, are very well abused, suiting different contexts. So therefore, maybe I'll start with very simple. So autonomy is the ability to act on its own, which is to say that the network configurations can be changed on their own without human intervention. And when I say cognition, I mean that there is an ability to sense the context, reason out what the context is, and then recommend some future behavior. Okay? And then self-organizing would mean that you can attain steady state, or whatever we call as optimal state, without any external control. Okay. So then I'll come to this point about cognitive autonomous networking. So we would all agree that it is important for us to understand the system concepts and the context in which the different applications are running, so that we can predict if the configuration is optimal for that application to be supported. For example, the configuration in which an IoT device needs to be supported is very different as compared to the context in which a smartphone streaming the video would have to be supported. And if the devices that are supporting IoT communication are subject to a network disturbance, say for example interference, or say loss of signal because of some kind of an obstruction coming, the reaction of the network to mitigate that situation would be very different from the way that you would handle a smartphone application. So therefore, to understand the context is one level, which is cognition. Second thing is, depending on the predicted corrective step, the system should be able to take that corrective step on its own, which is automation. Both are essential. So therefore, we say that cognitive autonomous networks are the key for supporting the evolution going beyond 5G and into 6G. We will do some more definitions. Now people talk about digital twin. So I want to start with this illustration where there is a heap of sand. So at what point do you say that grains of sand have become a heap? Or in other words, at what point is a heap just some grains of sand? So similar problem is also there when we talk about the definition of a digital twin. Some people show a dashboard of the network showing the state of different network elements and call it a digital twin. Some people show the map of a physical room like this, for example, chairs, walls, lights, etc., and say that is my digital twin. Some people show a network simulator which actually can predict what would be the traffic patterns if so many devices were put onto the system. So now the digital twin also is an amalgamation of all these different aspects depending on the purpose that it has to serve. So it is a combination of a dashboard plus a map which represents the physical structure, physical aspects of the network, or for example this room, plus simulator which has an ability to model the behavior of the actual items in the physical world. Okay, so far so good. So I will at some point in my talk also talk about why I talk about integration of cognitive autonomy with the digital twin, because that has some value to add. And I will do so by sharing a use case. So the journey towards an AI native network, as you rightly pointed out, has already started as part of the 5G journey. So with 5G, early 5G and even 4G, we had the self-organizing networks. With 5G, saw the advent of some proprietary AI/ML solutions. There were some standardized enhancements for network automation where we talked about ability to extract information from the different network elements, what we call as NWDAF, the network data analytic function, and then a mechanism for that to be exposed to the applications, and in this case it could be the management applications, and for them to then do something smart about configuring the network in the optimal way. Then 5G advanced was where we could say that there was a structured way to start putting in technologies inside the network so that you can support AI-based systems to do certain network functions. So the bedrock of AI is collection of data. So how do you collect data? How do you then create models out of the collected data at one network element and then share that across different network elements? Such things started to get introduced as part of the 5G advanced standards, which we call as release 18, 19, and so on. There was also, so since this was the first time when we started introduction of AI into the network, the focus was also on very initial use cases, like the ones that would support load balancing, enhancing energy efficiency of the network. Those were the initial use cases where we thought that we could probably try out AI/ML based techniques and algorithms to do something that is smarter in the network. With 6G, the expectation is that AI and ML functions would be integrated across all the layers. And more importantly, it's not about the network functions being implemented based on AI models, but also how these AI models get created also would be managed by the system itself. So I'll get to that in the next slide. But before that, just also wanted to show that, in 5G advanced, almost all the components of the network are AI enabled, in the sense that there is work that has already started to support extraction of data, creation of models, and then sharing of models across the system in the 5G advanced system. Okay? And then, as we say, 5G advanced is the stepping stone for introduction of AI/ML into the network, as well as stepping stone for 6G. And then finally, we can see how this actually evolves into what we call as cognitive autonomous networks when we get to the 6G state. So as I said, in the 5G advanced, we have the ability to create the different network functions that would be based on machine learning models. And then the change that you see, I mean, at least one of the changes broadly, is that the whole generation of the models will also be managed by the network itself. So the network management not only manages the network, but it also manages the way these AI models are generated. So all the aspects of transparency, trustworthiness, data privacy, all those aspects will also have to be taken care by the network. Okay, so now back to the digital twin. So we are now more or less on the same page in terms of what is a cognitive autonomous network. A network that has an ability to collect data, understand the context, and then predict future behavior. And then autonomous because that future action can also be taken without involvement of any external factor, for example, humans. Then what is the digital twin? So when we talk about digital twin, there are two broad categories of the digital twin. Since we are a community of people who are involved in the communication network, so from that perspective, there can be two separations that we can make. One digital twin is the digital twin of the system that would use the communication network. Say, for example, a factory consisting of the different machines that are set up, consisting of mobile robots, consisting of walls, consisting of, say, for example, doors, people moving around. So all those entities in the physical world, when they are represented in the virtual world through models where you can visualize animated characters moving, animated robots moving, that would be the digital twin of the physical world which is going to consume communication network. The second digital twin is the digital twin of the network itself, where we are modeling network elements and then their behavior. So essentially, if you say, what is the big deal about it? The network elements themselves are just software, right? So are we just replicating software from one computer, which is the actual running network, onto my PC and say it is digital twin? That's not the case, because the software, although is similar, but then if you start replicating the complete functionality, then it will become not scalable. So the digital twin of a network would contain again a scoped down version of the network element whose behavior we are most interested in, plus the actual state from the physical network. So now there are two parts here, right? So what we have to see is that these two networks, the physical digital twin plus the network which is there in this building, both of them have to be combined to predict what is the behavior of the physical object. Say, for example, if a robot moves into an area where there are walls, so what would be the kind of radio propagation issues that would be there when you have those walls? And then maybe the designer wants to know, if I replace concrete walls with, say, wooden walls, would there be any improvement? So all those changes can be done as part of the digital twin to understand the impact of physical changes on the communication network, as well as if you want to change then the network topology, what would be the impact on the actual application. So those things can be studied with the digital twin. So now combining digital twin with cognitive automation networks would actually give us an edge, because by definition, digital twin is able to predict what is the impact of physical network topology changes as well as physical device location changes on the kind of network that they experience. So that becomes a feedback loop into the cognitive part of the network management, which can then drive the appropriate automation behavior. So the last part of my talk here today is to take a use case where we show this thing in action, just to motivate that indeed, these different domains, when combined together, lead to something that is useful and practical. So the example that I take is a test bed that has been set up between University of Munich and Nokia. So this is Hamburg port. Okay. So the example is of how we have used a combination of all these concepts to solve a problem in this port area. Okay. So what is this port area? So this port area has got 3 or 4 ships, what they call as barges. And then there are different traffic lights, different, network elements, local applications at the harbor which can be categorized as EMB. Say, for example, watching the video of the ships, or controlling the movement of the ships and so on. And then on the ship itself, there are multiple number of sensors that are available, whose information has to be consumed by the application. Okay. So, and then in terms of data collection, there are different types of data that you are collecting from the base station, from the UEs, and these have been collected over 6 months, for 6 months, every 5 seconds. Okay. So this is the context in which this particular concept will be applied. So what is the problem here? So IoT requires high reliability. So you cannot lose a sensor which says that temperature was 100 degrees centigrade at one point in time when the optimal temperature is only 75 degrees centigrade. Because after that it might have come to 75, but the fact that one sensor item was missed, which means that you cannot do a critical maintenance operation there. So everybody is convinced that this requires high reliability. Now, what happens is that when the ships are moving across the harbor, there are certain areas where there are some obstructions that come up temporarily or permanently, which would lead to the deterioration of the signal from the network to these sensor devices which are on the ship. And these are long distances. Okay, so and these could be because the ship has gone long distance from the base station, or because of shadowing effects. Reliable service must be guaranteed even in this case, and it could be done in one of two ways. One way is to put 20 times more base stations so that there is no place where the ship is far from the base station, right? So then there would be no problem of radio propagation. But then again, like everything, the network resources, cost, etc. is also very limited. So therefore, we need to find a way where we optimize the situation in which the reliability for these sensor applications have to be catered to without compromising performance of other applications that are running, which are also equally important, but maybe at that point in time, not that critical to support certain parameters. So with that as the problem statement, we have these slides will be shared with you, so you can actually watch the YouTube video where these things are very beautifully explained. So we have the map of the harbor. If you see this is the real photo and this is the digital twin, where the ships move in the digital twin. Okay. So there are two ships that move for each ship in the real world. So if there is one ship in the real world, in the digital twin, two ships move. One which traces the actual ship, the one that is moving in the physical world, plus the one in which we predict what would be the position of the switch of the ship in the next 40 seconds. So therefore, you know in advance, after 40 seconds, what would be the kind of network that this ship would be subjected to, or the sensor devices on that ship would be subjected to. And then according to that, we take corrective action in the network, whether it is increasing the power, changing the tilt of the antenna, so that you can still support reliably the sensor operation. So very simple experimentation, and that actually led us to learn a lot of things in terms of, what is the kind of feedback loops, the latencies that need to be set up, what is the kind of intelligence that we need to put in the digital twin, what is the kind of intelligence in terms of software that is running on the operational network that needs to be put. So this was a very useful experiment that shows how integrating with the physical digital twin, by being able to model the actual movement of the devices on the ground, we are able to make better decisions in terms of network optimization. I mean, getting 40 seconds is like gold in terms of being able to make appropriate configurations in the network. So that thing gets enabled when we have cognitive autonomous network integrated with a digital twin. So essentially, this also talks about digital twin extended to simulate 5G with beamforming. So you can actually place a physical or virtual base station at different places in the digital twin, and then be able to predict, if you were to place a base station there, what would be the beam strengths available at a position X. So all those things can be done without moving a single screw on the ground. And then, another interesting thing is that some of these features, the beam tilt, etc., were not implemented in the physical network. But we could still check the value of these features which were not implemented in the physical network in the in the virtual world so that we could save a lot of time in terms of development of the features as well as the loss of material and time that happens when we have to do it, when we have to do the testing in the physical world. Okay. So with that, I talked about cognitive autonomous networks, which is essentially AI-powered network automation. So we see that they are the key enablers for the future networks because they lead to these two things at a high level. Performance improvement of existing network management functions and enabling of new functions. And this leads to simplification of management of these networks for the operator from focusing on execution of the actual thing to supervision of how things are happening. So the humans can use their intelligence to understand patterns over a longer period of time than to react at 40-second intervals. Then the value addition from integration with digital twin, as illustrated by the project which is called Planar use case, is that replica of the physical test bed enables us to evaluate features that may not yet be present in the actual test bed. Okay? So we talk about strength of India in software, and then hardware also comes with cost. So a lot of experimentation, whether it is with real networks or with universities, can be done by leveraging the fact that now software and AI have improved so much that we can model things very accurately. Separated but chain modeling of the network QoS and the application mobility is another thing that can be done, that is a value add that comes from integration with the digital twin. And then to summarize, so we saw that it's not that the journey started now. It has been there since LTE. So we had SON. SON has moved to cognitive network management, which we see evolving into cognitive autonomous network, in which the generation of the machine learning model itself can be managed by the network. Okay. So here the key difference is that the management plane takes a new role, managing AI-based functions on the user and the control plane. So with that, I would like to conclude my presentation. Thanks for your time.
Message. You dwelled upon cognitive autonomous network and gave us a digital twin use case from a real life scenario. So thank you very much for that. May I now invite Shri T.V. Sriram to the forum. T.V. Sriram is a global lead network operations at Accenture. And his topic today is intelligent network operations, fast track to future ready performance. Welcome, Sriram.
A lot of people had delicious lunch, and it's very hard, and it's a technical situation, session, and I'm trying to be as interactive and as interesting for you guys. Let me see how much I am successful on it. Just okay. So I was listening to the previous speakers in this panel as well as the previous sessions. I think for me it was a bit of a deja vu, and some of you may relate to this because at least I've been one of the fortunate guys to see the evolution starting from 2G, and I think starting from wireline and now going from 2G, and now we're talking about 6G. So these things are interesting, are exciting, and fascinating indeed. And sometimes I feel am I a part of a science fiction movie here, hosted by Sashidharan and his team. Okay, so nevertheless, what is happening is, while all these technologies are hitting us, both as a user, as a network operator, as a vendor, as a service provider like us, solution providers like us, how much are we adopting? Adoption is not a choice, but how much are we adopting, right? And I can relate or bring a very mundane example. Nowadays, we have something what we call smart TVs. Right, I don't know whether it will become intelligent TVs going forward, but we go to the showroom, and we normally go to a multi-brand showroom, and we go through and we take the life of that sales guy out, right? Can it do this? Can it do this? Can it prepare coffee? Can it prepare my breakfast? Can it put me to sleep? Whatnot, right? But at the end of the day, most of us can relate to me. You hardly get time to get hold of the remote, okay? You end up watching what is being shown, and we just end up there, right? So what I'm trying to say is, while we look at all these features and functionalities of everything when we are doing the evaluation, but are we able to exercise all of that, or adopt all of that, or utilize all of that? Probably that is where the rubber hits the road, okay? So here in my session, what I've just taken a step back, and I know it's going to be a bit mundane because it is all the dirty work, the heavy lifting which operators do in operations. So please bear with me, it'll not be as exciting, but I will try to see how to be prepared for whatever has been spoken earlier, because AML, we are not even scratching the surface in terms of the operational capability which we are utilizing. That's my personal opinion, okay? And then how we can help clients, operators, to get future ready, okay? So with that, okay. So I think this has been spoken about a lot, but I'm just giving a different perspective. So wireless has grown all the way, and now we are already talking 6G, and it'll keep going forward, okay? There's no end to that. And the other thing is also on the fixed line also, it's also catching up, and somebody, I think, Jeevan was mentioning that they are looking at 5G as the, what you call, backup link for MPLS, right? So that means probably they are coming into an inflection point in terms of the bandwidth they can deliver reliably. And it has been deployment, and tons of network infrastructure has gone into the field globally, okay? There are some numbers and there are some sources to it. But on the other side, interestingly, the OEM industry got consolidated. Right, so these are the 2-3 things which just keep at the back of your mind. We can't escape without talking about cloud in any forum like this, right? So cloud has been adopted, and one of the reasons which operators were really forced to adopt cloud infrastructure was the pandemic. I don't know how many of you, I've been in this industry for a while now, and during pandemic, 2 industries kept their heads up and actually holding the world together. One of them was the communication industry. And they grew leaps and bounds, and the demand was exponential, unprecedented demand. Okay, I know some of my colleagues in my OEMs who say, look, I'm not going to go and collect my purchase order, let them come and give it to me. Or I'm saying, no, I'm not going to supply this because my factory is full. Okay, I'm going to increase it by another 20% premium. Everything happened, right? So that means the growth has been such that we had to meet the demands of the world, especially during the pandemic, right? And 2 things happened. Cloud adoption happened in a very big way, accelerated way. The other thing which I was observing was the analytics. Data analytics also went into different use cases. I have been working with some of the operators to give them how to actually look at the movement of people or infected people in the network and how we can predict what can happen in the next district or the neighboring districts. So these were all some of the use cases which came and working with the government and with the operators. So unless until we, of course, I'm being an Indian, I'm very respectful Indian, but all of us, we will act only when there is fire under our chair, right? And that's what happened in that pandemic, but it has put a lot of people in different ways of looking at things, right? However, one thing which was very saddening is everybody looked at cloud as only cost takeout. Okay, can I deliver, can I bring my infrastructure cost down? That was the only driving factor, how to keep my cost low, right? But they missed out many things on how we can innovate, what else we can do with this infrastructure. And there's some, paper cuttings or statements given by different operators, why they want to go into cloud and how it is helping them to do this stuff in a better way. So everything has changed. Traditional networks going towards, I think you know all this, you're all an educated audience here, I'm not going to go through all the things here. It's moving from physical to virtual, right, too many people, AWS, GCP, Microsoft, everybody is in the play. The value chain is completely getting reconstructed again. So what are those areas? So it's more, I'm looking at it from a CSP, what is the CSP should be doing, because that is where these technologies are put into operation and they deliver the services. Right, of course, they have to look at completely re-engineering. Of course, a lot of people are doing, some of them are cloud-born operators, some of them are trying to move into the cloud. It's the different operators have different journeys and different challenges along with that. That is one thing, how we can leverage cloud, not just looking at it as a least cost option to deliver a service. The second thing, of course, is how do you optimize network operations, especially leveraging all the technologies we have, AI and ML, right? And the third thing is you have to offer new products and services. There is a big mindset. It's again, I've been in an operator myself for close to more than 10 years. It's still some of the, when I have the discussions, the mindset is pretty much a connectivity-oriented mindset, right? Okay, as long as I'm connecting, I'm fine, and let us not bother about the rest of the things. But there are a lot of people who are trying to do something in terms of applications and bringing platforms, all those things. But predominantly, I'm talking about majority of the operators globally. It's not just here. Globally, they are saying, okay, I'm a good connectivity provider. I need to figure out. So there are opportunities on how to bridge that gap as well. But my focus is going to be pretty much on operations today. And so if you're putting these investments in these areas, a desired output all of us or all the operators want is to how to improve revenue or jack up revenue. Because what happened during the pandemic, the exponential demand went up, along with the cost of deployment also went up. The revenue didn't go up in the same sort of slope. So there is always a cost to serve and a revenue. So the profitability got into a big sort of a challenge, right? How do you drive that? And of course, ARPU is all operators are measured on this. Also, if you have put your network to so much of strain and hard work, my strong feeling, or it has been, is unless until your employees are satisfied and happy, you will not have happy customers. Because the employees who went through this pandemic growth and the way they responded to that sort of a thing, for any operator has been unbelievable, incredible. Because I've heard a lot of stories, a lot of my friends and colleagues are working in this space. So it is unimaginable what they went through, okay? And during this pandemic, why I'm saying pandemic? Because that actually pivoted a lot of things in this industry, okay? So a lot of people went, they made their what I call the showroom, okay? Very, very jazzy, okay? Omni-channel, I should not leave the customer, he should be able to reach me at any point of time. So a lot of front office transformation happened, a lot of money was spent, okay? They can call, they can SMS, they can do whatever, and they'll be able to land. Similarly, on the back office, cloud, okay, moving to cloud or disaggregated networks, different ways of putting all the things in place. But there is a huge chunk of talent which needs to be upgraded, which is sitting in the middle office, which is operations, right? That has not been jacked up or modernized to the level at which it can support both the front office and the back office, okay? And most of the time, operations has been looked at just people or technology. Because most of the clients or customers whom I talk to, oh, we have got the best tools under the sun in our network. Okay, fine, what do you do with those tools, right? And if you go and tell them, okay, tell me how do you measure this, or how do you actually, are you able to get this visibility in this space? There are a lot of things. This is one. Second thing is, a lot of operators also build data lakes, right? Data lakes, everybody built that data lake. And all of them did was grounds up data. Okay, I will collect everything in my network, put all the probes in place, put everything. And I'm a bit, was thinking when Satish was mentioning, there'll be a lot of AI, ML, intelligence, a lot of data is going to come. There is already tons of data which you are not able to handle and which you are not able to make sense of, and how do you put it into smart decision making, right? So it's going to be more and more of that, and that's where probably I think it's a bit more sort of segue into what I'm going to talk about. Okay, I think I've spoken about this. Moving from cost mindset to innovation mindset is very key, and it also needs to be done in operations. It's not just a marketing or a product development sort of agenda, but it has to go across. So there should be a big technology business interconnect for any organization to achieve this thing, and that is a cultural alignment which the organization, it's not easy. Believe me, I've been in this and trying to do certain things like this. It is not easy to get a few people together on this sort of a mindset, okay? And I think some of the points Satish also mentioned, if you have to give good service, overbook the bandwidth, or overbook or over-engineer your network for unlimited capacity. Right, and we have seen this in Backbone, we have seen this in a lot many other places, in Access, wherever, but that is not going to be any more feasible in terms of commercial, as well as in terms of making sense of, you can't just deliver service by just jacking up your capacity. So from there, you have to look at customer and employee experience more, which can help you in this. So it is going to be a shake-up from status quo to how to become future-ready, because 6G, AML, what can, digital twins, all of them are going to hit you, not very late, but very, very soon. Okay, so it's like Synops is a sort of a platform which combines the capability of the human and machine intelligence. It's a cloud-enabled platform. And we are been working with a lot of clients across industries. So when I talk about operations, while it is all about network operations, but this particular platform we have been able to deploy across industries to support their operations and leapfrog the maturity levels. I'll talk about the maturity levels in a second. So what it does is diverse data. So network in the early stages used to be just billing data. That was the only data which we all know, right? Then after that, lot many things happened, then billing data, then you call, transactions started happening, then you have customer data, then you have now crowdsourced data, now you have social engineering feeds, whatnot. Right, so there is a diverse set of sources of data, right? How do we actually look at the right combination to make some sense out of it and drive a decision making? From this data, make some sense. Data is just information, okay? It can throw any, it's like a, what do you call, I'll call diarrhea, okay? So it keeps coming from any nook and corner of your network, right? So how do you handle it? Okay, so based on that, you have to make some sense out of it, drive some intelligence, and see how is it you can do your decision making, whether it can be closed loop automation, or it can be shutting down a few things, or can be, okay, this product is not giving me sort of profitability which I would like to have, so I'll shut down this and do something else. So it can be anything. And of course, how do you drive experiences? This is also an important piece because operations, as I told you, has always been looked at. We had the technology, oh, we have the best people in town. Okay, so what? Right? Because today, for example, if I have to take an instance, you're not fighting people on the other side. A security sort of a threat or a security, it's done by bots. Okay, you're fighting a machine. You can't fight a machine with manual, of course, human intelligence is unlimited, but human capacity is limited in terms of time, in terms of the response you need to give, right? So how can you look at hyper-automation to do all your regular mundane stuff, voluminous stuff, non-complex stuff, so that you free up human intelligence for doing the creative work? So that is the other aspect of this Synops framework. And also, if you are able to give that headwind or headroom or bandwidth to your most creative and expert people, then it's easy for you to do a lot many things. All these things have to be put across a work orchestration, right? We don't want to do everything and then finally somebody gives a command or logs into something and say, okay, I will give this command. That's not what it is. How do you actually implement or integrate it into your work orchestration? And it can be network service fulfillment, it can be service assurance, it can be customer operations, it can be billing operations, anything. Okay, this entire range, how do you actually drive all these things? And last but not the least, I'm not going to do this just for the heck of, because I have a technology and I have some set of people who are cool in doing this. I want to drive business outcomes, right? Whether it is NPS, whether it is profitability, whether it is efficiency, or whether it is going to be your employee experience, right? So with this, we were able to move a few things from transactional, because you can't look at it as a very transactional thing, right? Okay, I've been doing this for so many years. I will add 2 more things and I will do. It's a very, very incremental approach, which will not take you to where you want to be. Okay, you need to look at it from a long-term perspective in a very disruptive way, because as we heard the previous speakers, there is a lot more going to hit you. If you don't know how to drive a manual car efficiently, forget about doing it with an EV or something else, or maybe autonomous. Autonomous, of course, we don't need to drive, but we will have to sit inside, right? So based on our experience and research which Accenture conducted across, the research was conducted about a couple of years, so just when we were coming out of the pandemic, across about 1,000 plus CXOs, cross-industry and cross-functions, of which about 50 communication service providers were also included. Okay, so based on that, we found out there are 4 levels of operational maturity. The stable one, which is like the standard one, which everything is there, you have a framework, you have some compliances happening, you have some processes defined and all that stuff. That is the very basic stage. Then you go to the efficient, which is like a bit more automated. You are running RPAs, robotic process automation, and the mundane stuff, which is something about the Lean Six Sigma and about business excellence and all that stuff. The third piece is the predictive, where you have started using data and to drive a bit more of predictability into the, okay, what will happen, what if scenarios you build, and see what is it you can do. Okay, and the last is what we call the future ready set, where actually you are driving efficiency and profitability and driving business outcomes. The predictive mode is still about very operational and transactional. Okay, when I talk about future ready, this is more about how do you improve the stakeholder experience across board. So based on that, what we observed was CSPs, or communication service providers, traditionally they are good in technology because it's a technology intensive industry, right? So automation, they were very much higher than the industry average. So that is a very good platform to be in, or a very good position to be in. But are they leveraging that capability or strength to deliver some of the few things? Probably not. Like I said, it's all very much operational. Okay, can I reduce this? Can I address the cost? Can I be a bit more this? That's about it. And future-ready organizations, what we thought, about 7% in that sample size. Only 7% was there. Okay. So from a comms perspective, 70% were there in predictive area. That is the stage of the maturity level. But moving from predictive to future-ready, it is actually a chasm you have to jump. Right? That is why no incremental approaches will take you there. You need to really be a bit more disruptive there. So how do we do and what do we do? Before that, each and every level, as the thing says, we used to talk about just technologies or people or process. But this, we had put a 4th dimension to it, which is the data piece and the data insights, not just data. So if you look at this, these 4 dimensions give you a good, more holistic view of how you can drive your operations to the future-ready mode. So what does it mean? Just this, if you want to take key takeaway of this presentation is just this. Okay, so I would request, I know some people are tired, but I would request to just give me 5 minutes to go through these 4 slides. What do we mean by foundation? As I told you, stable mode of operations, everything is there. You have a benchmarking process, you have. All I want you to do is, I don't know if this works. Okay, I hope it's there. So look at the talent, how this transformation is happening on the talent side, and how it is happening on the workforce distribution side, and how it is happening on the top quartile and the optimized operations in terms of what sort of impact areas we are looking at. Okay, if you're in the base foundation mode, everything is there. You have the right shoring option because I'm talking about operations, so it's across board. We do a lot of offshoring and onshoring and right shoring and all that stuff. SQF, KPI, everything is there. SLAs, everything is there. But you're still focusing on just efficiency, experience, quality, and compliance. That is your quartile benchmarking on the right-hand side, the bar chart. And if you see on the spider diagram, you're looking at just SLA and maybe some productivity. That's about it. Okay, from there, if you move to the next efficient way of automation, human and machine combination improves. So you have started putting more automation in place. But if you look at the talent, you have technology experts, your SMEs or SMEs as you call them. You need also business advisors. So you need a team which understands if you do this, what is the impact from a business perspective? Okay, what sort of a business outcome can I drive? And on the right-hand side, if you see the tooling, all those things happen, RPA, the process maturity model, all that, right? Troubleshooting, enable, all the frameworks, all these things are available there. And on the optimized operations side, if you see, you are slightly moving towards predictive operations. The triangle is becoming some sort of a hexagon, maybe, yeah. And you are able to drive about higher productive real-time insights you have started using. Business outcomes, touchless or zero touch is still minimal there. Go to the next level, insights-driven or predictive. You have completely moved from, say, the first phase you are highly transactional, a bit more automated in the second phase. The third phase, your agility comes in terms of data scientists, AI experts, all these people follow in. And if you see the optimized operation, that spider diagram is also a bit more wider in terms of addressing all those 4 dimensions. And you are slowly started getting some business outcomes in place. The last but not the least is and this is where 70% of the operators are today based on the survey we have conducted or the research we have conducted, okay? And from here to jump here, it's as I told you, it's a chasm, it's not easy. You can't just do a few things and go there. But if you see this, your talent mix is completely different. The way you are looking at the optimized operations in terms of future readiness, real-time insights, high productivity, you can define all these things for yourself. Okay, I'm just giving you some generic terminologies here. But the top quartile benchmarking, if you see, you are able to address everything. So efficiency, experience, quality, compliance, human-machine combination, business outcome, and touchless or zero-touch operations. So this is something which we have been engaging with different clients across industries and helping them to improve. This is powered by Synops. Okay, that is the platform which I was earlier describing to you. So does it stop there? How do we do this? Okay, so we look at value as in 360 degrees. Okay, it's not just financial. Okay, we are looking at financial is of course there, CapEx, OpEx, that is the base minimum business case you have to develop even when you go for any engagements. But beyond that, we are looking at experience, not just the client, but also the employee as well as the partner, because it's going to be a highly partner ecosystem-driven models going forward, right? So each and everybody has to work towards the value you want to deliver. So partner experience is also equally important. Sustainability, of course, we have, and whatever I'm saying is not theory, it's not a presentation. We have projects which are being measured like this today, and we'll be happy to share more information as and when required. So if you see sustainability, like everybody was talking about energy, a lot of things, these things will consume a lot of energy as we move forward, right? So how are you going to be, every corporate has got their own sustainability goals in terms of carbon credits and being carbon neutral by so-and-so date. Right, all those things gets plugged into this particular framework. Talent, of course, how do you develop talent, reskill, upskill, and also how do you do change? How do you manage attrition, right? Inclusion and diversity across board. Again, pandemic gave us a lot of lessons in inclusion and diversity, how the workforce can be completely different, where you can't even think of from where these people are coming from. And apart from that, the customer has got I want, apart from this, these are the 2-3 things which I want to drive. Custom also is available. You can plug it there. Okay, and this gets actually measured and governed in a tracking mechanism, all completely online on this framework. Right? So we call this, and we measure our contracts also TVE, or total value enabled for the client. And there is a internal meet or dashboard which keeps represented. This client, we have delivered so much of value over the period of so much across industries, across function, and across clients. So how do we reach there? I think most of the things I've touched upon, just to summarize on this, you should know what you are going to achieve or what you want to achieve. Okay. So if you are clear about that, okay, when I say think big with strategy, you don't need to hire some consultants and do something. You say, look, my business is here, I want to bring this business to here at some state, right? Have that as a customer-focused or as a business-focused sort of an approach From there, you can take, if you're saying, okay, today I'm operating at, I'll tell you the traditional way. I have 500 people in my NOC. If I bring them to 300, I'm good. That is a very transactional, incremental approach. Okay, so you have to see, okay, if I bring 200, what am I going to deliver in terms of customer experience? What am I going to deliver? Am I going to add to the bottom line of the company? These are different things which needs to be thing, and this can be tied back to what it is. And of course, business technology interlock is very, very critical. I don't know how many of you, some of you would have done the DevOps and the different ways in which you drive operations or projects, even in system integration. You all something called user stories or customer journeys. All these things are now new things which have come up being in an agile workforce. You can't do this sitting alone in your technical war room. You have to bring business people in, and they have to tell you whether it makes sense or not, whether it is assurance, whether it is fulfillment, whether it is new product development, whether it is new market. Technology, business. When I say technology, I use both networks and IT. Technology is common, ICT. Right, so don't get me, okay, what about IT, what about network? I'm talking about all technology, because there is nowhere, no function which is technology averse. Everything is very, very pervasive now. So do that, that is also going to be, so that you'll be able to figure out what exactly will help them, so the organization or the team comes on ground to this. The second thing is know the key steps. Okay, if you have automated to some extent, what is the sort of hyper automation you can look at, and how can you free human creativity from that, right? So here again, a lot of people have done a lot of attempts in terms of making sense out of the data, but you have to accelerate it a bit more, because there is going to be more and more data being sent to you, and you need to look at how do you do this. The third important thing is, a lot of operators are in different stage, okay? And the 3 to 4, the predictive to future ready actually has to be a leapfrog. You can't walk across, or you have to actually jump, because it's a chasm, we need to jump, right? So there, it needs to be a lot of mindset, and change is going to be very key there, and the alignment and the appetite of the organization for change is also very important. So it's more of that, and you can only do, as an operator, as an OEM, only so much. So build your strong ecosystem for partners, and that we saw again, now no operator will say everybody has got Microsoft or GCP or AWS in their ecosystem. Oracle, you call them, like there is a different bunch of operators or different players in the ecosystem. So what do we get? And whatever I'm saying, as I told you, these are all based on research and proven metrics, right? It's not that this is a desirable output we want to have. This is something what we said, okay, if these are the future-ready organizations, as I told you, 7% of them are there. And so it's about 1.7x or double 2x efficiency improvement. When I say efficiency, you can define it in different ways. The basic simple way is cost to serve. Okay, for the same dollar of revenue, I'm able to reduce my cost by 2x. Right? And of course, the profitability because of it, which actually moves your bottom line also up. So these are the hard, tangible benefits from a business or a number perspective. But at the same time, as we saw in those 4 transitions from maturity levels, your talent mix is much more improved. You are able to reskill your talent, make them future ready, and both your customer experience and your employee experience goes up. And of course, your ecosystem relationship also matures. So the choice is there, and while, as I told you, the majority of the CSPs based on their technology excellence are already in predictive stage, but they have to do more and fast. Because 5G, everybody is looking at it in a deployment mode. That's how it is. But at the same time, you need to bring the middle office also equally up, so that you don't need to worry about how the operations are running. Will it be able to cater to my increased demand or increased technology stuff? So you can focus on your business and customers, which is more where you should be, rather than looking at technology is available to everybody and anybody can do anything, right? So try this across these 3 dimensions of people, process, technology, and of course, data insights. So that's probably brings an end to my thing. Thanks a lot for your patience. Appreciate it.
Hello, hello.
Hello.
Yeah, sorry. So thank you, Sriram. Your presentation is a reality check. So that's the right word to use for your presentation. And moreover, I think there is an author called James Clear. He wrote a book, Atomic Habits. So he suggests that if we bring a small positive change in our life and do it on a continual basis without losing our momentum, then collectively it brings a very sea change in our life over a period. So I think that's what he's trying to allude to. So thank you very much. Now the panel is open to take questions from audience. So if you have any question, please feel free to address it to one of us. Yes, please. There is a question there.
Paul Dayanadi. I'm Paul Dayanadi. My question to is CTO, his name is Robert. You were telling NOMA is already implemented, is planning to be implemented in 6G. Are you sure about it? In your lecture, you were telling that NOMA, non-orthogonal multiple access.
Yeah,
because
one model of this is already for 5G is being evaluated.
But
It's going to be the next level of it is going to go in 6G.
But in 6G, it is already standardized that OFTS will be the modulation. OFTS is a modulation technique. Are you aware of it?
Sure. Sorry for butting in. If I may take that. So 6G, nothing has been standardized yet, but like sir indicated.
Because the Doppler effect delay is minimized. Intersymbol interference is minimized with the Doppler delayed interference. That is being minimized in OFTS. That is why I was wondering how NOMA is coming into picture.
Yeah,
because
so
NOMA is a value. I have submitted an IEEE paper on that. That's what I'm asking this question.
No, you are right. But all I'm trying to say is that nothing has been decided or standardized yet. So different types of waveforms are appropriate for different types of scenarios and applications. And for places where Doppler is an issue, probably OTFS, like you are telling, is more appropriate.
Will intelligent reflecting surface antenna will be the optimum solution for a 6G?
That also is not cast in stone. I mean, there are different studies which indicate how much percentage gains that you get from it. But it is certainly a very promising technology that needs to be evaluated. But
Now let us put very, very clearly, whatever the technologies we have mentioned is all evolving. No standardization has been done, but as I mentioned, in 2020, the IT working group put a roadmap of what should be the network by 2030. So this is the applications that we want. That has been decided. So, of course, there are different, as I told you, not only NOMA, we even talk about spatial division multiplexing also. So the technology, what is going to evolve, a lot of research is going on every area. As he told, RIS is one of the key area, the reflective intelligent surfaces, not only the small even the large intelligent surfaces. These are a lot of research is going on in a number of countries on this particular one. They are trying to bring in, as I mentioned during my speak, even as a paint, is not going to be a real device. RIS is not going to be a device such that it could be even take a form of a paint also. There's a lot of research is going on, but that is the one field where people are looking at because of the simple reason I told you, N and K. When you want to have N APs connected to K users, N greater than K, then your reflecting surfaces should be automatically done. That's obviously one of the choices which people are looking at.
Thank you. Is there any other question?
Yes, sir. I'm Dr. Jagdish Shivare, professor and ex-scientist ISRO. Sir, my question, we are expecting 6G by 2030 in our country. But my friends in Norway say they are using 7G and 8G and 10G in Japan. So if it is true, why we are not working on 10G instead of 6G?
No, sorry. I would like to take it from an industry perspective. I may not have a very good answer for you from a technology standpoint. Sandeep, you may have, and you can contribute if you do have. But, these are all test beds. So they are very, very algorithmic models that the people must be working on. But when it comes to the real rollout, nobody has rolled out anything beyond 5G. So 5G is something which is commercially been deployed and being exploited. And 6G testbeds are ready. However, to bring it to a commercial size, it will take minimum 5-6 years. So that's where we stand as an industry today. I don't know, with any of the panelists, you want to add anything here?
So they are using for what purpose, 7G, 8G, 10G? Is it not approved or just...
Give it to him.
Friends are there throughout
Yeah, sure.
the world.
Sure.
Please.
No. Give it to Sandeep. He wants to add something.
Hello. Hi. First of all, just to address your question, when we talk about G is always related to the degree of standardization. So till now, only 5G is standardized, 6G is going to come. So whatever G that you're talking about, that might be a generation of some other technology, not the wireless one. The 10G, 7G. So when you say internet speeds, that other speeds may be from the fiber and other things. This G that we are talking today is about the wireless technology generations. So G is the generation that can be, even if you look at the Honda scooters, they are launching 6G, but that doesn't mean that a wireless 6G. That is 6th generation of Honda scooters. Just to answer your question. Yeah, this is not wireless.
Okay, thank you. I think it's a very good way to conclude it while all of us are laughing. So thank you very much.
One more, last question.
Okay. There's one more question. Yes, please.
In terms of affordability, normally whenever I'm a chartered accountant, so I would put it from the financial point of view. Whenever we are launching a product, there's a market survey, we go to the customer, we understand his requirement, we understand his pocket, and then we try to do the backward working to get the financials right. I think that's a prudent way of doing it. Now in this, probably I think even for 4G, the revenue which we are getting, the ARPU of 180 rupees, is not sufficient to make it into, to make it viable. So what would be the ARPU or government support you'll require so that it's a viable thing? It doesn't go into, it doesn't become a bad project where, public money is being, is the ultimate funder of the whole project. So what would be the government subsidy support you'll require where government comes in as a financer to put in the money for the beneficiaries? So the beneficiary is paying almost 180 rupees per month as an ARPU. So I think that's a pertinent thing which...
Yeah, so coming from the telecom fraternity, possibly I can pick it up. However, this is the nature of this industry, right? I mean, the licenses are sought for almost 15 years, and then the money's been paid to the government. Initially, it was upfront, and then it was monetized over a period of 15 years. Erstwhile, say, 20 years now, the term has come down. But nonetheless, that is the nature of this industry. It's capital intensive. And that's where you see there are very limited players who are in the fray. Moreover, all the new technologies are not necessarily expensive. The new technologies are very efficient. So the spectral efficiency of those technology is doing a lot of justice to the price resource, which is the spectrum. So I'm able to do a lot more megabits of the data now in the given chunk of a spectrum compared to what I was doing in the previous generations of the technology. So similarly, with the new 6G coming in, I would actually be able to pump in more data in the given chunk. So I think that way, we are already monetizing more. And why a new technology? That's a question which I sensed in the room as well. So I think the answer truly lies in our own behavior. When I drive my car, a few years back, I used to download an MP3 app and listen to the songs. Now what I do? We all turn on YouTube. It is running. and then we are driving car. So we're just listening to the music, and for which we're consuming a lot of data unintentionally on the network, I mean, without even watching it. So that's the behavioral change. I think it is driving the new technology and the consumption on the network. It's many a times not purposeful, but it's happening. And with the 5G launch, within few months, since October 2022, we had seen that the data had gone up 40% on the network. So, and the tariff you see is the plan for 4G and 5G is same. However, the data has gone up, and hence the ARPU has gone up for 5G users, because you're paying for the extra data that you're doing on the network. So your behavior is driving all of this, and plus the new technology as well. I don't know if you want to add.
Hello.
Yeah, it's on.
Yeah, yeah.
It's on.
So I just have one more perspective to it. I don't know, probably you said you're a CA or financial guy. Okay, so the government SOPs can help you only in delaying your cost investment, delaying your cost. Still, as an operator, as a service provider, you have to look at how do you monetize your technology, right? Because like 5G is a fat 4G as of now, like what Jeevan also was corroborating is. So how do you actually monetize 5G? That is going to be a thing. And for us, India is in an interesting situation, because as I told you, I've seen this 2G transformation coming wherever we are today. And I don't know how many of you realized we completely leapfrogged 3G. We didn't go into 3G big time, okay? But we did some investments, but we leapfrogged from, when I say 3G, we didn't go to the UMTS one, we went directly to HSDPA, which is like 3.5 or 3.75, whatever they call it, right? So like that, there are some advantages for being late starters. But for your question, my perspective, my view, don't take this as Accenture code, this is my personal opinion, okay? Government subs, because why I'm saying this is, government subs have been given in Europe, and they have given, like, for example, I don't know if it is like 25 euros a month or something, that is the sort of fee they have to pay for the spectrum, and people can go and launch private networks, right? So that is one way of looking at it. But all these things are not sustainable, in my opinion. Government SOPs will only take you, maybe they can give you a spectrum, I'm just thinking aloud, maybe they can give you a spectrum holiday for a few years, but that will only address your cost part of it. But still you have to figure out what is it you're going to use the technology for monetizing it. I think that's where the crux is.
Agreed.
Yeah, just to add a couple of things. First, from the government side, you already know, we have already brought up the 6G mission. We are going to support the right sphere, maybe in the R&D or the particular type. Yes, government support will be there. Please don't expect it on the subsidy side or anything, that's going to be the later. You need to think when the new technology rightly comes, it will not necessarily be expensive, as you rightly pointed out. The entire business model will go for a toss in 6G. Mark my word. The entire business model will go for a toss in 6G, because the network itself, if you see, I was mentioning a lot of networks. We are going into second network, we are the information technology, so the entire stuff is completely changing. So as you rightly you mentioned about captive non-public networks growth is coming up. These captive non-public network means you and the citizens himself going to be a partner and thing. The operators are going to be the wholesale agent, and the retail agents are going to be you and me like citizens. So that is another model that is evolving everywhere. So 6G definitely is going to be, as I rightly told, if RIS really becomes a plane, you're just going to do a specialized paint in your walls and then have a RIS controller. You yourself are going to take a revenue out of it. So the business model will completely go for a toss. Everything is going to change. So don't compare with 5G to 4G, because even the cellular concept has gone for a toss in 6G. So why not a business model go for a toss?
True.
Thank you, sir. We come to the end of the first day of 6G India tomorrow. 6G, maybe during the tea time. 6G India 2023, the first conference on 6G. May I request our special address, Sri Robert Ravi, to present the memento to the distinguished speakers. First to the chair, Jeevan Pelgaonkar, the Vice President and Head of 5G Solutions, Reliance Jio. To Satish, to Sri Ram. Both come the same country. And may I request Jeevan to present a memento to the Sri Robert Ravi. Thank you, ladies and gentlemen. We'll have a tea break and then see you tomorrow sharp at 9:45. See you. Thank you very much.